Before we begin this digital event, we want to acknowledge the traditional owners of the land. As many of us are watching in locations all around Australia, we pay our respects to the traditional owners of the country on which we all live and work. We recognise their continuing connection to land, waters, and community, and pay our respects to them and their culture, and to the elders both past, present, and future.
Hello everyone, we are back. Welcome to our 6th episode of Azure in Action, our digital innovation series partnered with Intel, where we get to explore the transformational solutions built on Azure, the world's computer. Throughout this series, it is our intention to give you the opportunity of direct access to industry experts, so that together we get to explore how Azure can scale your organization and redefine the cutting edge of technology. And of course, discuss with the pioneers and innovators alike who have done just that. There's a lot going on in the world at the moment, and yet you've still chosen to spend an hour of your time with us. Thank you very much. It's very much appreciated. I'm your host, Dasmika Gokul, and I'm an AI cloud solution architect at Microsoft. I'm a woman with South African Indian heritage, and my pronouns are she, her, and hers. I have dark brown hair, dark brown eyes, and I'm wearing a black and white blouse today, coming to you from Brisbane, Queensland, Australia. We mentioned that the purpose of Azure in Action is foundationally steeped in learning from pioneers and innovators alike, and our guests today more than exceed that description. It is my absolute pleasure to be in discussion today with The Yield, an agtech company driving sustainability through real-time machine learning to solve real challenges at the farm level and then throughout the supply chain for growers. I'm joined by The Yield's solution architect and systems engineer, Frank Carter, and their chief technology officer, the wonderful Chris Mendes, who I also have the pleasure of working with very closely at the moment. Today, we will be discovering how machine learning at scale can empower you on this journey towards your sustainability commitments. We'll be exploring why sustainability is simply just good for business, both now and into the future. And we'll also see how The Yield are deploying custom machine learning models, deep learning models too, at scale to help agricultural producers grow better, scale faster, and reduce risk. Specifically from a technical lens for our audience today, we'll be zooming into event hubs and the federation patterns that The Yield are using as they consider to scale into other geographies, the types of models and neural networks that their data science teams are using for microclimate predictions and what that actually is, and also their machine learning journey to date and how that's led to Azure, specifically Azure Machine Learning and Azure Databricks as their next steps. As always, at any time during the session, we'd love for your participation. So please do take the opportunity to get involved, post comments, ask any top of mind questions using the Q&A tool, which we will pose those questions to both Frank and Chris later on in our session. Now, of course, to set the scene for the episode and to give us a bit of background on The Yield and how they are disrupting the agricultural industry, I'll pass it over to Chris.
Great, thank you so much, Taz. Hi everyone, I'm Chris Mendes. I'm the Chief Technology Officer at The Yield. My pronouns are he, him. I have black hair and brown eyes, and today I'm wearing a navy blue sweater. And I'm coming to you from our offices in Sydney in Surrey Hills. I want to introduce you to The Yield, and whilst I love telling this story myself, I think there's nothing better than seeing a short video which captures so much more than I'll tell you. So we might cut to that video now.
Climate change is making weather more and more unpredictable. We can't control Mother Nature, but we can use technology to help growers understand her moods.
The stakes are high. We have burgeoning population growth. We have climate change like we've never seen before. And if we're unable to solve some of these challenges, then quite literally people will go hungry.
The Yield's an Australian agtech business. We focus on taking the guesswork out of growing. The purpose of the Yield is to feed the world without wrecking the planet. We use real-time weather data at the farm, field, row, right down to the hotspot level. That data then goes through Processed, which manages all this network of mesh on the farm. And then it goes into Microsoft's Azure cloud, where we apply our machine learning and we deliver our applications to help growers know when to plant, when to irrigate, when to feed, when to protect and when to harvest. The really big problems we're trying to do is increase yield, reduce input costs, reduce risk, and increase environmental sustainability of our food production systems. We have to learn to collaborate and come up with new business models and work out how we're going to solve these very big problems and challenges together.
Yeah, great, thanks. I really love that video. I think really what it does is summarise that we are in a position now of increasing pressure on all industries, but agriculture in particular, with climate change and this growing population. And we really need to start using data to make a difference to how we do things, to respond to that. Back to you, Taz.
Thanks, Chris. I think there was a line that Roz shared in the video there, feed the world without wrecking the planet. Really powerful to see what's going on in the world and how you guys are playing the role in reducing that impact. I guess what really strikes me from the Yield is how revolutionary the product that you're building is. It's precision farming. So for our audience, think precision medicine, but then apply that from an agricultural perspective. And it empowers different personas across the supply chain journey to make that value of corporate sustainability not just something that we see, but something more actionable. So incredible to see, and also just celebrate the work yourself, Roz, and the entire team has done on making microclimate predictions, I should say, a possibility. From my 2 cents, not only is, I guess, sustainability an imperative for us to just collectively aspire towards, we are very much seeing a groundswell of cultural transformation in corporate Australia and New Zealand, where sustainability is, slowly but surely becoming an inherent part of how we show up and do business. So I guess from your perspective, Chris, and this is probably something you talk to every single day, but why should sustainability be something more deeply rooted? Why should it be a centric pillar that a business strategy pivots from, compared to just a typical sort of nice to have?
Well, and I know it's a bit cheesy, but at core, it makes financial sense, obviously, and I think that's where a responsible business has to start from. But we're living in unprecedented times, Taz, and I think we've got to have a response to that. And it can't just be one person or 5 people. It's got to be everyone, and not just as individuals, but as corporations. And I think we have to respond to that and make a difference to the way the planet develops.
Yeah, love that. Maybe we'll use the term corporate ownership. But the growing climate crisis, to your point, and you've said it so nicely, we have to think differently and also act quickly towards a circular economy.
Yeah.
When I say that, meaning the broader industry, we're certainly making progress in APAC with newer environmental, social and governance, or ESG, reporting frameworks and standard committees, which is great to see. But, from everything I've seen and read in the industry, I know there's certainly a lot of companies out there that do have hesitations. If they have excessive ESG emphasis, is that going to undermine their competitiveness and compromise on their returns? Simply put, will they struggle with balancing shareholder value creation and sustainability, as if those two things are mutually exclusive? I know the Yield does excel in doing it both, and you guys are really setting up that standard there. But really interested in your take here, Chris. How does the Yield balance profitability or increase profitability and sustainability at the same time? And what type of data do you have to support that?
Great. Yeah, look, I'd love to share some slides with you just to go through that, and we'll start with just a simple view of what is the data that we're using, and then go further than that and talk a bit further. So look, we do pull data from a lot of different sources. We're pulling weather data, obviously, from our own sensing technology that's on the ground, and this really matters because measuring where you are growing is very different from just pulling data from a weather service. And we do take data from weather services, in fact, quite a few of them. We're using IBM globally because it's a global service provider. We're also pulling data from Weather Zone, and we're pulling data from satellites as well. And we don't use the images as such. What we do is we derive a bunch of signals, and we basically take that, we build predictive models around that combination of that data to predict the microclimate, but we're also using it to predict harvest volumes, timings, and quality. And we combine all of that with what the growers inherently know, so their best practices. And the combination of all of these things we're calling a digital playbook, which is like a set of game plans for growers. And we feed the data into that game plan so they know what decisions to take. And we're going to come back to this digital playbook a little bit later, and I'll get you, a good look at it so we explain it a bit further. But let's talk now about the numbers that you asked me about. And, I like to put this in practical terms, and I think this is what growers really respond to. We're really about the digital transformation of agriculture. And, this is something that you've heard about in other industries. I mean, obviously, share trading, banking, all of those things. There's been huge digital transformation there. And I think agriculture is one of those last bastions of digital transformation because it's been so hard to do, in fact. And so, look, really what we're now looking at is how does it make a real material difference on the ground? And I think for Australia in particular, but globally, the use of water. And, we're seeing up to 57% reduction in water use for some of our growers, some more than others, obviously, depending on the types of crops. There's a winery that talks to this point who's a customer of ours down in Victoria called Tabilk, and they swear by it. And basically what we do is we give them a water balance in the app that tells them how much water, is left in the crop, if that's a sort of sensible way to look at it, or to explain it. And that gives them a very real and material way of knowing when to do watering. We increase spray opportunity by 47% or up to 47%. And this is really important, actually. Spray windows have a huge impact on the quality and quantity of a crop that you'll get from a particular field. And obviously, minimising the use of chemistry really matters, and that saves money, but it's also good for the environment because you're not putting excess chemistry on the ground. And it's not just for the farmer. Obviously, everyone around the farm is affected by this. So that's really important. Some of these chemicals are very complicated things to apply, and you've got a complex formula to work out when can I do it or when should I do it is probably a better way to look at it. And if that's a hard thing for a grower to calculate and to calculate many times during the day, and we do that for them, and that really does help. But the other thing that I think is quite fundamental is extreme weather events. So you're looking at frost on the one hand, very cold or very hot, and both of those things are obviously bad for plants out in the field. And we greatly increase the reporting of those things to growers so that they can actually take action before the problem happens. And, obviously the weather is a huge impact on all of those things, and it's something that growers really worry about, and our system makes that accessible and very real for them all the time. We might move to the next slide. So yeah, look, how does that impact ESG? And I'd like to say it's obvious, but sometimes it isn't obvious. We're really enabling growers to do more with less, and that's going to impact their bottom line greatly, but also clearly it's their ESG, and it's something that we will continue to sort of help them with over the years that we're working with them. It's about reducing their water use. It's optimizing spray, labour schedules, so getting the right people to the right place at the right time for harvesting and processing, mitigating the events of heat, helping them with price realisation. So, am I going to get the right price in the market based on the projections of my harvest? But ultimately, it's about de-risking what growers do every day and making a real difference to our planet. But it's wider than that. There's more to talk about there. We'll go to the next slide. Really, we have to look at the entire value chain of growing. In Australia, interestingly, what we do on farm, for every dollar on the farm, there's $1 spent either side there in total, and an opportunity there for savings. In the US, it's even more. It's for every dollar on farm, it's $2.50 either side. And really, we need to look at the entire value chain. So our data and all of our analytics, while it helps the grower, that same information can be used in the entire value chain pre-farm. So this is looking at suppliers. So the genetics provider can get feedback about the success of their crop, and they can actually help the grower then to optimize what they're doing. Obviously suppliers of things like spray and fertilizer and so forth. But then on the other side, there's even more value that we can help with, and we do help with. And this is all about processing the food once it comes out of the farm. And, in the simple cases, it's about market. How do I package? How do I market? Do I know how much stuff is coming? Labour scheduling, where do I harvest from and when? But for more complex processing, things like wine, you really can help with the logistics and the use of plant and equipment. And it means saving money by getting the right things done at the right time and in the right place. And that's a huge benefit environmentally as well.
Yeah, right. Being good for the planet is good for business as well, and vice versa.
Sure is.
I think, hearing from your perspective as well, and I'm sure certainly for everyone listening today, you solved a microclimate weather prediction problem, which not only is incredibly challenging from like an operations research or data management and architecture perspective, since there's thousands of models being deployed here, and also cost optimization and balancing that. But you are definitely going to be modeling a multivariate problem with high dimensionality in the data set.
Yeah.
Which is, really an interesting problem to actually dissect and tackle. So curious on how are you modeling the data with so many variables, and then also balancing out the personalization on crop predictions?
Yeah.
And then how are you doing that in a timely manner that is also easy to consume for the user?
Yeah, absolutely. I'll get into the architecture actually in a little while, but before we do that, let's just take a quick look at the app. We won't animate it, but we'll just have a look at a picture of that now. And, what I wanted to do is very quickly show you what the digital playbook actually looks like. So what you're seeing here is a generic version of the app. And you can see the little light blue lines, and those blue rows are showing the grower by day how many hours opportunity they have to spray or to, do some other activity. Could be harvest, for example. And if you can actually click on each day and drill down, and it shows you exactly which time of day. But you can also see some green, amber, red indicator lines as well, which are showing you can actually use that for application of chemistry, where it's not just a do and don't. You can actually have a more complex application. But also it's just showing the risk of diseases. So it could be the risk of, red mite or a powdery mildew or something like that. And this is basically the way the app presents what is essentially very complex information for a grower to make a decision.
Great. Yeah, I love the simplicity and the thought behind the digital playbook. I think a lot of product managers, I'm sure they struggle with that question on explainability of machine learning and how are we making these predictions accessible, but then also being able to justify the statistics and more of the maths behind the why. So yeah, really great to see. And I think that makes it quite clear for a lot of personas and stakeholders as well, just to understand what we're doing and what's happening in the back end. But now we have seen the front end, would really love a bit of a deeper dive into that systems and the architecture piece.
Great. Well, let's have a look at the architecture diagram together. And this, I'm laughingly calling it the architecture diagram. My team always gets stuck into me about how high level this is, but you've got to start somewhere. So let's have a look at it. The centerpiece of this is a processing pipeline that we use for moving data through our system. And it's really important in all of these systems where you're doing AI to make sure that you've got a standard presentation of information with respect to time. In fact, that's one of the biggest factors of what we do. We're pulling a lot of data in on the left. We use an event hub based system to gather the data and process it. And essentially it's like a refinery, and you can see on the left we've got processed there, pulling in the data from our IoT sensors. Soon we'll be adding Davis weather station data to it. We've got the weather company data from IBM coming in, and a range of other data, and that covers a multitude of things, including our own data science. Our own data science is a data source that we process. That goes through this refinement pipeline. It gets pushed up into Cosmos DB, which we're using for fast access to the data, and that is then read by a bunch of microservices that drive the apps through an API, but also all of that data gets pushed downwards as well into the data lake. And it's from the data lake that we do all of our data science. The entire system is basically running on, it's containerized, running on Docker, Kubernetes, and Keda to scale. We're using a lot of spot instances as well throughout the system, and this is making it increasingly efficient and cost effective for us. But really what I want to do is, as you were sort of asking earlier, Taz, just focusing on the data science. We've got a bunch of workspaces. We've kind of hand coded a lot of this, and we'll talk about it further later, why we did that and where we're going to. And from that, we produce a very standardized model, which is basically a containerized model. And we've got a workflow, a pipeline that helps to deliver that into a production environment. The one thing that we run at much greater scale than everything else is weather prediction. And that's something that we'll drill into now. And in order to do that, I want to hand over to Frank Carter, who's our system architect. So Frank, can you tell us a bit about yourself and give us an overview?
I'm Frank. I'm the data and systems architect at the Yield. I've been here between 4 and 5 years. My pronouns are he and him. I have dark brown hair, blue eyes, and today I'm wearing a black t-shirt and black trousers. I'm also located in the Yield Sydney office in Surrey Hills.
Thanks, Frank. Frank, what attracted you to the Yield and what kind of keeps you here?
It's been my passion and I suppose training in large-scale systems over many years. That's what I've been doing for a long time. So anything that's got sort of large-scale, interesting and new data attracts me. I have worked in other areas of large-scale data, but the driver to come to the Yield was to start doing something that actually helps the planet and is good. Some of my other large-scale data projects were not so beneficial to the world. So this is my penance. I'm here to help this time.
Yeah, I think it's great to be able to make a difference every day, Frank. So look, without sort of me blathering on too much, I think we should just throw up that slide about the data science execution engine.
Sure.
And maybe you can talk to this, Frank, and tell us all about it.
Sure. The way we do our data science execution is with a producer-consumer model, because those tend to scale really well.
Yep.
On the right-hand side, we've just got the job producer, which is a fairly simple piece of software. When it is called to say, please go and either train or predict for a bunch of models, it will go through our metadata about all of the sensors we have, looking for the appropriate sensors, and then it will produce a job description, which it will put into the queue, and hundreds or thousands of those will go into the queue in quite quickly, within a minute or two. Then on the consumer side, we have a Kubernetes cluster running a bunch of spot instances. which will also fall back to non-spot if we run out of spot instances. So it is safe, but we've rarely not been able to invoke with spot instances. The number of instances is managed by Kida. So we can look into the queue and say, is there any work to do? If there's no work to do, then there'll actually be no resources spun up at all. So when there's no training or predictions to do, we're not consuming any resources at all, not even spots. As the queue fills up, Kida will spin up more and more instances that will take those job descriptions from the queue and execute them. So I think we have at the moment just an arbitrary limit of about 300 jobs, because we found that to be sort of roughly the right balance between how quickly we need the jobs to finish and spiking the load. But we could change that arbitrarily. We have on occasion spun that up to several thousand, and it works fine. But to summarise, the fact that we can horizontally scale those containers based on the number of messages in the queue means that we've got the best of both worlds. Not only can we finish a batch of work extremely quickly, but when we don't need to do any work, we're not consuming any resources. So that's a really good scalability story.
Yeah. Thanks, Frank. I think that's a classic use of cloud as well. And in fact, it's the optimal use of cloud.
Agreed.
And I think that in itself, speaks to, environmental concern. You're not using things when you don't need to. We're using spare capacity when it's available. I think it's a great story.
Yeah, love it. Thank you for the insight there, Frank. It was good to hear about that horizontal and vertical scaling as well with your containers, and you're using Kida there, which really important when it comes down to that whole paradigm of scalable AI and how much that does just dictate on the hardware and the network as well. But now that we've seen it at like a really high level on how it works, we'd love to see if we can do a bit of a demo of this piece in action.
We definitely can do that, although it's very hard to see AI actually running. But we are going to look at our live production system now, so we might switch to that particular view. And look, this is live. This is actually a monitoring system looking at the weather system running. And you can see that we've got a couple of runs that have happened. That was yesterday, and this one here is this morning's run. I'm going to throw to Frank, and maybe you can tell us a bit more about this, Frank.
Sure. Once you've got several thousand models running sort of fairly regularly, in our case twice a day, and the number of models that we run actually is proportional to the number of clients, and in some respects how big those clients are. As you can see, so there's one of our clients who's got 682 models there, one of our larger clients. At this stage, having effective monitoring is really important. And Chris, if you could zoom in on...
I'll just do the start of this morning.
Yeah, that's a good idea.
Do you want me to go a bit further? Yeah, I'll go a bit further.
Yeah, a bit further. That'd be good.
There we go. We'll just do the kickoff.
Sure. Oh, is that showing for you?
Yeah, there are some spikes there.
Oh, yeah,
sure.
sorry.
They're very fine.
Just my screen, they are very fine. So what each of those spikes are is that they are one model run. So they're a prediction or a training for a single sensor. And the height of it shows you how long it's taken to run. So you can see that many of them taken between 2 and 3 minutes, which is about what we would expect. Now, if we saw some taking very large amounts of time, that would be sort of an indicator to us. And we actually have monitoring on the height of those spikes so that we know if something is out of the normal range. You'll notice that there's a bunch of controls up the top that let us burrow into different types of things. And one of the things that is important is we can look at the exit codes or the status of those various runs. Once you've got several thousand models running, especially as they're derived from hardware out on farms, then failures are inevitable. There are things that we can't control. Farmers will accidentally turn off power. Cables will get cut. Cows will eat things. So failures are unfortunately a normal part of life. But what we can do with this system is we can look at sort of the numbers of failures on a bunch of different slices and say, yes, that's what we expect. We know that we've got 5 sensors that are out or disabled on this particular farm. That's okay. We're in the process of fixing those. So this really gives us an insight into the operational status of our weather prediction system.
And Frank, what was some of the tech that's underneath the hood here? And
Sure.
I'm just talking about the monitoring, obviously.
Yeah. So the dashboard is built in Grafana, which is an open source dashboarding system. The metrics just for the monitoring, not for our general data, is kept in a database called Influx, which is particularly good for this purpose. Actually getting the metrics into the system is remarkably easy. We internally developed a bunch of Python decorators that we use through all of our software to produce metrics for the system. And that allows us to very simply collect metrics from all of our software and push them into this sort of system.
It's come in very handy for a lot of things, actually, though.
We use it extensively.
Yeah, it's huge. It's huge. Thanks for that, Frank. That's awesome.
You're welcome.
Love it. Thanks, Frank. From my position in working with you guys, I get to see the back end of that. It is really great to see what a grower or one of your scientists would actually be seeing and what that experience looks like as well. I'm keen to dive into a little bit more on the technical part of this. I'm sure our audience has noticed it's a very event-driven architecture using event hubs to write data into Cosmos DB. Obviously, makes a lot of sense given ingestion and processing of data is happening from IoT sensors. Of course, your traffic's going to be controlled by throughput units and handling the larger transfer rates. But curious to know, how is your team doing capacity planning for what I'm assuming is a dedicated events hub cluster? And what does that process actually look like from a performance tuning perspective?
Yeah, it's an interesting one, actually. There are a bunch of issues around that are worth exploring. Just something that I've never told you before, but that we actually do use the same technology that we just looked at to monitor and track performance of the processing off event hubs, which is the first step. When we built this system, it was pioneering in many ways. It was early days for Azure. We started out when some of these things had only just gone GA, and so we didn't really know what it was going to be like, and we had to try it and see. And we've actually not plumbed the depths fully yet, because what we've found, of course, is that by instrumenting and monitoring, we've said, okay, there's an issue, there's a problem here, where's the problem? And you then go and optimize and fix the problem. And what we did was spent a lot of time learning about, what is the optimal way to bulk up your messages and send them through for processing? Do you do it one at a time? Do you do it in batches of 10? Do you do it in batches, So there's a bunch of things that we've learned there. We actually haven't finished all of that optimization yet.
What does that experiment process look like on that journey from determining, is it a batch of 1, is it a batch of 10, batch of X? What does that experimentation look like?
Scary sort of examination of what's happening on your production queues.
Yeah, sure.
So there's a lot of, okay, we're going to try. We started out with the simple case, why would you do it any other way? And then learned by looking at, okay, as we grew our customer base, and this is classic startup, you don't always know, and you don't always provision. So you really have to grow your customer base, observe what's happening, respond quickly. Yeah.
Is there an element of predictability that you've used there to predict out the batch sizes?
We have started to learn
Yeah.
that, and in fact, we've got well, now we know that there's an optimal batch size that we are using, and that depends on the hub to some extent, but where you are in the processing pipe. But we now know. The other thing that we sort of had to learn along the way is about how to scale the compute. And we've actually come to the conclusion that at the moment, it's not a good idea to sort of change the scale of compute at each hub. And the reason for that is that it just takes a long time for let's just say, the coordination of the workers to settle. And it's actually slightly better right now to just pay the price of having a certain amount of compute sitting there.
Yeah, makes sense. Speaking on scale, as your team, I guess, considers scaling this out into other geographies, of course, that's going to mean that practically you'll have to maintain multiple event hubs in different regions and then also different namespaces. Maybe this is a question for you, Frank. What is the federation pattern that you guys are using to consider as you consider this challenge, really?
We're just doing the initial architecture proposal for that, which I got out for review by the rest of the team. The proposal at the moment is to make them as independent as possible. My preference for geoscaling is to run everything as independently as possible with GeoDNS routing clients to the most appropriate location. That way you get both scalability and resiliency, because you can use another region as a full backup in the case of a failure.
Yeah, makes sense. So just, following those best practices also with how you're doing geo-redundancy in Cosmos DB, I assume as well. Yeah, right. I guess switching gears a bit into more of the machine learning side of things, what type of underlying models, algorithms, neural networks are you guys using, and what were the reasons behind those choices?
Yeah, it's a really good question, Taz. I think the principle we work on is constant vigilance, and we do a lot of experimentation to understand what the best model is at the time. And so, when we started this, we might have had a very simple linear model for barometric pressure, for example. But over time, you sort of realize with the more data you have, the more complex the problem might become, that we may need different model classes. And so we do a lot of retraining. We do a lot of model evaluation constantly, especially for more complicated things like harvest prediction. And in some crops like, wine grapes, for example, that's gone through a range of models over many vintages now. In fact, so we've got a range of models that could just be, the boost class. We might end up with, in some cases, LSTMs and even CNNs for some things.
Interesting. We'd love to know a little bit more on that LSTM part and neural networks. I'm sure our audience is very well aware, LSTMs, convolution neural networks, that's mainly computer vision, natural language processing and the like. How are you using that? I'm assuming, it's lateral thinking that we're applying from one technique to the other here.
Yeah. Well, we're lucky. Yeah. We draw on, we've got a great team. We draw on quite a few doctorates sitting in our team, and that's something that we value highly. We work with UTS as well, so we're partnering there, and we're getting a lot of input all the time. Yeah. So, what we realized, or what one of our team realized, is that we deal with very complex problems, as it turns out. And when you're looking at harvest prediction for wine, you might have many thousand features going into that model. And this is where you really need to think laterally, and that's where we came up with this idea of using image processing techniques actually for harvest prediction.
Yeah, that's awesome to hear. I guess, speaking of image processing as well, Azure, it sounds a lot very similar to what we're doing with Azure Anomaly Detector, which is a COG service, but they're using like computer vision techniques to actually amplify the amplitude, and they're using the Fourier transform to recognize signal in the data set. So it sounds like you're using a very similar technique, but in the process of time series data as well, right?
Yeah. That's it. Yeah. And look, we may be changing our perspective again, over the course of the next year. We'll figure that out as we get there.
Yeah, for sure. I guess speaking of that, your journey to date has been around 5 years old, especially on the machine learning side of things. But, what have been the challenges on that journey, and how has that come to the conversation on Azure?
Yeah, and I think this is the multiple aspects to this. It's partly just the journey of a startup, and I think it's also reflecting the development of Azure over that period. Azure's been growing. It's a very fast-moving cloud and fast-developing cloud. When we started, we weren't sure at the start of exactly what these models were going to look like, and that's evolved over time. The start of the journey, they weren't containerized, and they were running on a monolith, and we've come a long way since then. And look, Azure ML's changed a lot over that period as well. When we started out, we couldn't achieve the scale that we wanted to at a really reasonable price point using Azure ML. We've constantly come back to looking at that over time. And we're now at a point where we've got a great system running there. It's awesome and cool and does all of that great scalability that Frank showed us earlier. But the thing that we want to move to is standardization and using a set of standard tools. And whilst I don't believe we can have the commercial edge that we do now without special models, and I think that'll always happen for us. What we are looking at is how do we deploy, can we get standard pipes from people like Microsoft and the Databricks team, and can we use, so we've got a very homebrewed pub-sub system there. We're looking at, can we leverage some of the compute in Databricks and the techniques in Databricks to do that instead, which really does matter. It's going to accelerate our development. It's going to make it easier for people to join the team.
Yeah. So what I'm hearing here is flexibility and governance are the key sorts of facets that we're looking at from like an attached compute perspective, but then also how does that conversation come down to ML ops, for example, which so many processes are involved in maintaining that and doing that at scale as well. But what do you think is that recipe for success when it comes down to scalable and then also repeatable machine learning? I'm sure there's a lot of people in the audience that are keen to learn from your experiences and journey as well.
Yeah, and I think this is one of the things that people hear but may not always believe. You start with getting your data right. And so, I'm seeing the pain there, Taz, from your own experience. But that whole data pipeline, it's there for the app and all that. That's great, and we need that. That's what the growers use. But it's also there. Really, it's primarily there to get the data right for the machine learning.
Yeah, couldn't agree more on that. I think there's a real paradigm or hopefully a paradigm shift in the industry, going from being just model driven into more data driven, and that's where your value is created. And I'm not saying anything new there, but it's more so where you're focusing your time in actually making sure it's scalable, repeatable, and explainable going forward.
Absolutely.
But what has been those biggest sort of takeaways that you've had from creating a scalable SaaS business on Azure?
Look, I think the one thing that you've got to say has been a constant is observation and adaptability, and making sure that we are really focused on scalable architecture, best practices, getting the compute right, getting the data storage right, looking at the cost. How do we do this at the most efficient price point possible? And we can't always implement that, but we strive to do it whenever we can. And I think now we're on that next stage of standardization and best practices from a data science industry, best practices perspective. So I think it's a combination of getting your software and data right as a good basis for launching your data science scalably. The other thing that which I think has been a difficult journey for us, is getting your data models right, getting your standards right. There are no real industry standards for agriculture. And I mean, there aren't a lot in other industries either, but agriculture is very raw. And I think that's something that journey is something that we're going on now. It starts today for us.
I think that also really ties into the AI at Scale initiative that's coming out of Microsoft Research, for example, where, it's to do this successfully now, it's not just, a script and an experiment in a notebook, again, not saying anything new here, but it's a combination of things. It's pre-trained models, it's software, it's network, it's hardware, it's how do you actually look to high performance computing as well. And those are the factors that will dictate success going forward, rather than just how do we optimize the neural network. As interesting as that is, it's about the broader sort of architecture at play, which I'm sure we're all very familiar with as well.
Totally.
I think there are some questions in the chat, so let's have a look. Just scrolling up there, would be really careful. I think, what have been the challenges so far with solving that microclimate weather prediction problem on that journey? I think we've alluded to a lot of the problems so far, but if you could summarize that in maybe on a data modeling perspective, that would be quite interesting.
Yeah, I mean, look, one of the things that we were lucky to get right at the beginning was an understanding of time. I know that sounds weird, right? So we've been very strict about defining, we talk about phenomena, and there's a range of things that we've had to do to make sure that the data is contiguous for the data science, no holes. If someone goes out into the field and the cow eats the sensor, I mean, the people literally have run them over and cut them up and things like that. What you don't want is to have your data scientists having to understand that. Right, so that's one of the things we've done. We've provided a contiguous stream for a place. So this whole data model of how does the world look? How do I make a stream of data that is constant for my data science team is something we put a lot of effort into.
As well.
Yep.
Yeah.
The other one is a good understanding of time. I think people really struggle with that, and rightly it is complicated. And we've done a lot to model that and make that data available to the data science team. So those are two of the first big challenges. And then look, the one that I think we're facing more now than ever is an understanding, a real world understanding of accuracy. Because good, or what does good weather look like?
Yeah. And is that going to be relative to different crops that you're using? And then from like a modeling perspective, what does that actually mean and the results of that?
Yeah. Well, actually, there are some metrics, and that's one of the, those numbers I showed you in the slide earlier.
Yeah.
I think where we are now is feeding that back into the models. Have I got extreme weather correct? How accurately have I predicted extreme weather? And that's what matters. It doesn't matter that did I get it? Was it 37 degrees or 38 degrees? Well, actually, it doesn't matter. What really matters is how often and how far ahead I picked it.
Yeah. Speaking of that proactive sort of thought piece here, and I think you alluded to this at the very start, how do you think this technology might help farmers in drought areas better plan and minimize loss?
Yeah, I think this is really hard for them. It's a difficult time for them. And this is about basically having an understanding, because these guys buy water rights, and this is about managing to those water rights and saying, okay, we think it's going to be a very dry season. We are starting to look now. I mean, what we do right now is 14 days. We look ahead 14 days. And I think where we need to get to is to extend that and start doing more advanced analytics and looking at seasonal prediction for things like rain.
Yeah.
And giving the grower the ability to say, well, it's going to be very dry over this season. But in the short term, even now, just getting a better prediction of how wet it is, how hot it is, and turning that into, for example, not just a temperature or a rainfall, but what's the crop going to look like? What's it going to do to the plant? And that's where we make the difference.
Yeah, for sure. I think you took us through the value chain at the start. Would be really good to hear, how can AI be used to support sustainability outcomes in other industries from your perspective? Yeah.
I mean, look, there's some obvious ones and directly applicable from the things we're doing. Even, for example, what we do for microclimate prediction, how can that apply to building management, for example? How do we use that for optimizing the use of power, for instance? The other side of it is logistics. So if I've got a better understanding of the parameters for my use of plant and equipment, I am going to make better decisions and use power, labour and systems more optimally. And that's something that impacts the bottom line, but also impacts the planet greatly.
Yeah, for sure. I think, Frank, you had talked about using Keto a little bit earlier.
Yep.
How are you using the different AKS clusters for machine learning and, serving out the APIs itself?
So this is not my area of specialty. Our brilliant DevOps guy set this up, but my understanding is that we've just got the same one management or one AKS, but it's got different pools. So the different classes of software that we run are assigned to different pools that have got different underlying hardware. So the virtual machines that we provision for data science are ones that have been chosen to fulfill those workloads well, and the ones that are driving our APIs are a different class. So and that's actually what we've done, from my understanding, with the data science stuff, is that we've got one pool that is the spot instances, and then we've got a fallback pool, which is the non-spot instances that get invoked if we can't find a instance in the spot pool.
Right. Okay. Yeah, it makes a lot of sense. I think we were kind of alluding to that a little bit earlier with how the queues are formed and how the jobs actually go into the cluster and are served up. So I think we have one more question in the chat here as well. How does overall an event-driven architecture allow for that experimentation from the yields team when you are looking at approaching new systems and services?
I think it's also important for the team for everyone to sort of know that it's not just a production environment, obviously, for us. We do spend a lot of money on cloud. It's expensive, but it's necessary. So there's a few key principles there. Obviously, we've got, dev, test and prod. We don't have an integration environment, actually. And effectively, dev is our integration environment. Yes.
Do you want to mention the data science environment? Because I think that's really important.
I was going to go there, and the flavour, and you can talk to this, Frank. The flavour is, though, full access to the data, the production data. And I think it's worth talking about that as well, Frank. Do you want to share?
Yeah, sure. So one of the challenges we had, and I think a lot of people have early on, is that for data science, you can't have pretend data. Your models end up being wrong. So the question is, how do you give the data scientists access to full and proper data without compromising your production systems? And what we ended up doing was writing or developing a virtualization layer on top of the data lake that presented the data scientist with virtual layers on top of the real data. So if the layer was empty, then they could get a read-only version of production data, but they can also write back their own versions into a virtual layer. And if they say use that virtual layer, then they get what their experiments are.
Right.
And that's been really, really powerful. We're at the stage now where we can do a historical back test, which is about, we make 7 weeks, and if a model works for the previous 7 weeks and does better than production, we are very, very confident when we release it that it is a good model. And that's because of the ability to roll back time and run things in a virtual layer.
That, I think you mentioned something in that conversation which made me go have a bit of a light bulb there. Have we considered managing, putting differential privacy on top of the data set where we're managing different from data? Is that something for consideration going forward, Chris?
There are a bunch of things that we're starting to look at now that because we're looking at changing some of our underlying tech, we've basically got a data lake using a non-standard form. And I think we're going to get to a point where we, possibly will end up moving our files to a more generic industry standard format. We've kind of resisted that to date because I think, you want to be sure, you want to trust it, and we just haven't been there. But that's growing on us now. And once we've done that, it actually is going to change our access patterns to the data quite a bit. And I think that's something that we're going to have to review in the next sort of year. Starting June, probably, but 12 months.
Interesting to see how we can get that done on Databricks, and then also on Azure ML with the integrations into the diff privacy libraries and all of that too.
Totally. That's where we're going to go.
Yeah, love that. I believe that is all the time that we have for questions right now, but our team will be staying online a little bit longer in the chat to answer anything top of mind if there is anything for you there. But overall, what a great session. So many good takeaways from today's episode. I think the top two in my mind is, of course, scalable AI. It's not just model driven here. I think, as I mentioned a bit earlier on, there is this perception in market where we do have to focus a lot on optimizing the neural network. But when we are thinking about how do we deliver the quickest time to value for scalable AI, it's going to be, of course, as you can imagine, a data-driven conversation. But it's looking at how we can leverage those pre-trained models, the software, the network, the hardware. What does that conversation look like from using a GPU, an FPGA, or further high-performance computing as well? And then, of course, as Chris alluded to with the brilliant data science team that is at the Yield, they're looking at lateral model ideas and thinking and inspiration from deep learning and how we can apply that to other problems and techniques. Again, not saying anything new in that perspective. I think a lot of data scientists do that to date, but it's always a really exciting way when we're able to dissect our data and look for different techniques and transformations when we are doing engineering on the data set itself before feeding it into the model in order to really optimize how we're reaching the metrics itself. Overall, wow, thank you so much to the brilliant Chris and Frank for joining us, for your partnership, and then also for sharing learnings and your products. I think it's very much revolutionary for sustainability and the grower supply chain. So thank you very much for being here today. We really appreciate it.
Oh, thanks, Taz. Thanks for the opportunity.
Thanks.
And of course, to you, our audience, thank you for tuning in today. Thank you for your time and your space to join us with Chris Mendes and Frank Carter from The Yield. We've had some great engagement, and we hope this session has answered some of your top of mind questions for machine learning at scale, The Yield being the prime example of how that can be possible. Thank you greatly to our partner for Azure in Action, Intel, and thank you to our team behind the scenes for the amazing work that you guys have been doing all this time. But once again, thank you all for joining us for Azure in Action episode 6. We'll be back soon with Azure in Action episode 7 on how you can drive better data science practices in your organization. See you then.